Today we're going to be solving a matrix equation for x given an A, which is a matrix, and B, which is another matrix. In order to solve this equation, we're really solving the equation AX equals B. And to solve this type of equation, we have to find the inverse of A, which we're going to call A inverse, and we have to multiply it to the left side of both parts. So we're going to do a to the negative first times ax equals a to the negative first times b. Whenever you have a matrix multiplied by its inverse, it gives you the identity matrix. So we can rewrite a to the negative first times a as I. And any matrix multiplied times I, which is the identity matrix, gives you back the matrix that you multiplied. So this becomes x equals a to the negative first times b. Now in order to find the inverse of A, we're going to have to use row reduction and augmented matrices. So we're going to take an augmented matrix of the form A augment I, where I is the identity matrix in dimension 3. It has to be dimension 3 so that it matches the dimensions of A. And we're going to use row reduction until we get to the form I augment A inverse. Whenever you get the left-hand side to equal the identity matrix, the right-hand side will be the inverse of A. So in order to save time, I've written out the row reductions on this side of the board. As you can see, on this side of the augmented matrix, you have the original matrix A from the problem, and on the right-hand side, you have the identity matrix. Using row reduction, we find the equation in the form of I augments A inverse. So to go over our process, we took row 2 and subtracted 2 times row 1 to get here. And then we took row 3 and we subtracted 2 times row 1 to give you this augmented matrix. And then we subtracted from row 3 2 row 1s and we get this augmented matrix. And then we added for row 1, row 2, and row 3. And then finally, we negated row 3 to give us the identity matrix on the left-hand side and A inverse on the right-hand side. Once you have the once you have the inverse of A, as we have on this side of the board, you multiply it times matrix B, which was given in the problem. So, shown here, we have A inverse, which we found using row reduction, and we have B. So you multiply A inverse times B by using matrix multiplication, meaning you have to take every row and multiply by every column to give an individual point. So in this case, we took 3 times 2 plus negative 1 times 4 plus 3 times 3 to give you 11. And we repeated this process multiple times to give you x. And that solves the matrix equation for x. Thank you very much.